Okay, for this lesson we're going to take a look at quadratic functions in general form. So we've already done the vertex or standard form. The general form is going to be y is equal to ax squared plus bx plus c. A, just like with our vertex form, determines if it opens up or down and is also going to affect the vertical stretch. The b is going to influence the position of the graph, moving it up to the right, up to the left, down to the left, or down to the right. And c is always going to be the y-intercept, because if I put x as 0, then what's going to happen is this is going to cancel out, this is going to cancel out, and I'm just left with that c value. So first, if we're taking a look at this graph, where I have f of x is equal to negative x squared plus 2x plus 8, well, I can see that the graph opens down. I have a vertex up here at the point of 1 and 9. So the coordinates are just 1 and 9. And in this case, it's a maximum value because it opens down, and it's a max of 9. The equation for the axis of symmetry is going to be x is equal to 1. The x-intercepts occur at these 2 points at -2 and 4, and the y-intercept, as we've already said, occurs at 8, which matches our c value. The domain and range of this, well, domain is the same for all these quadratics. It's just x, where x is an element of all real numbers, and the range is going to be y, where y is less than or equal to 9, where y is an element of all real numbers. If I'm comparing the vertex form and general form, I can expand out the vertex form to see how the different values relate to the a, b, and c, or the coefficient of x squared, the coefficient of x, and the constant term of my general form. So the first thing I'm going to do is I'm going to square out the x minus p, and I'm going to say that f of x is equal to a bracket x squared minus 2px plus p squared. And I still have the plus q on the outside. I'm going to multiply a by all these terms, and I'm going to get ax squared minus 2apx plus ap squared plus q. As I've already said, in this case, the coefficient of x squared, or the a value in my general form, is still just the coefficient of x squared. In this form, a is still equal to a. The coefficient, or what's beside just the singular x, the b value, is everything that's in here. b is equal to -2ap. And finally, the constant at the end is made up of all of what's left here. The constant, or the y-intercept, would be the same as a times p squared plus q. Now you can see in example 2, they rearranged that formula that we had, saying that if b is equal to -2ap, then when I isolate p by itself, I'm going to divide both sides by -2a. So p would be the same as -b over 2a. If this is true, then in the quadratic function, y is equal to 5x squared minus 15x plus 7. Then I can say that p would be equal to negative of -15 over, in this case, 2 times 5, or 15 over 10, or 3 over 2. My Q value is going to be what the value of y is when x is equal to 3 over 2. So in order to do that, I'm just going to state that y, or q in this case, which is what we're actually solving for, is equal to 5 times 3 over 2 squared minus 15 times 3 over 2 plus 7. We could also say, given our formula from the last page, that if C is equal to 8 times P squared plus Q, Q would be the same as C minus AP squared, or 7 minus 5 times 3 over 2 squared. This is going to give me 7 minus 5 times 9 over 4, or 7 minus 45 over 4. Well, 7 over 4 would be the same as 28 over 4 minus 45 over 4. And when I actually subtract that, then in this case, I'm going to get negative 17 over 4. So the vertex of this would occur at the point of 3 over 2 and negative 17 over 4. For example 3, how many x-intercepts does a quadratic function have in each of the following conditions? So in the first case, I have an axis of symmetry where x is equal to -1, and my range is y is greater than or equal to 0. Well, if I draw this out and I say that x is -1, that's going to be my p-value. And I say that y is greater than or equal to 0, that's going to be my q-value. And when I actually draw this, I'm starting at the point of -1 and 0, and because it says greater than, it's going to open up. Any time that my minimum or maximum is at 0, then I'm only going to have one x-intercept. For the second example, it says I have a vertex at -4 and -2. So I can say -4, -2 would be about here. And the y-intercept is negative. Well, there's actually two possibilities that could happen here. Either it could have a negative y-intercept that is below the vertex, open downwards, and have no solution. Or it could have a negative y-intercept that's still higher than where the vertex occurs, and have two x-intercepts. So in this case, I actually don't have enough information to determine whether it's two x-intercepts or no x-intercepts. I just know that it can't be one X-intercept. There's just not enough information for it to be definitive. For the last example, it wants us to sketch a graph of a quadratic function that has an axis of symmetry where x is equal to 1. So I'm going to draw that axis of symmetry where x is equal to 1. It's got a minimum value of 2. So I'm going to start at the point of x equals 1, y equals 2 for my minimum, and there's my vertex. It also passes through the point of -1 and 6. So if I have the point of -1 and 6, because it's going to be symmetrical about the x-axis, it also has to run through the point of 3 and 6 in order to be symmetrical on both sides of that axis of symmetry. And then I can extend this out further. So the 3 points that I know for certain are going to be -1 and 6, 1 and 2, and 3 and 6. I'm going to write what the quadratic function is in both vertex and general form. Well, in vertex form, it's going to be y is equal to x minus 1 squared plus 2. I could use the vertex in one of the points to confirm the a value, or I can know that it has the same shape as y is equal to x squared, because from the vertex it goes left 2 and up 4, which means that my vertical stretch is just 1. Then, to convert it into general form, I would once again, so this is my vertex, I would once again square it out. Y is equal to x squared minus 2x plus 1 plus 2, or state y is equal to x squared minus 2x, and then 1 and 2 are going to make plus 3. And there's my general form.